Hello students, welcome to RD Chemistry. We'll solve some organic questions. Question number 1. Identify A and B in the following reaction. Let me take this first reaction. We have got tertiary butyl alcohol. So CH3 thrice attached to the same carbon atom, and then we have got OH. Let me take this potassium permanganate in the acid medium. So whenever there is an acidic medium, generally what will happen? Protonation takes place on the alcoholic group. Correct? So this should be removed. So we'll get CH3, CH3, CH3. This is a positively charged. Now what will happen? From the neighboring carbon atom, proton can be lost to give the alkene CH2, double bond C, CH3 and then CH3. Again, this molecule can undergo oxidation to give corresponding compound, that is a CH2O, formaldehyde and keto compound CH3, C double bond O and CH3. Right? C we can see that is a CH3 twice CH2, that is here, and corresponding next compound is a CH3 twice CO, that is available. Okay, and it is also there in the option here, B option it is there. Correct. Now we'll go for second compound, next compound. Here we have got CH3 thrice, correct? CH3, then OH. Now there is a basic medium. Whenever there is a basic medium, it will look for the acidic hydrogen, there is alpha hydrogen. There must be alpha hydrogen on this carbon atom which is attached to OH. Alpha hydrogen is not there, therefore there is no oxidation, there is no reaction. So the compound remain as such. The answer should be option number C. Clear? Question number 2. Which is the most acidic compound? See there, in all the cases, we have got OH group. Phenolic OH group is there. Phenolic OH acidic in nature. If there are electron withdrawing group like NO2 group, the acidic character goes on increases. Therefore, C is the answer. Okay. Which of the following compounds will react to the 5% solution of sodium bicarbonate? First of all, sodium bicarbonate is a weak base. Now all these compound contains the phenolic OH. Okay, they will stronger acid to react to the weakest base. Okay, therefore, which is the strongest acid which contains more number of the electron withdrawing group, acidic character increases. Therefore, A is the answer. Question number 4. The ethereal linkage COC is cleaved by. So we have got, okay, the ether linkage. If there is a protonation, then followed by, if there is a Br minus I minus, it will be attacking the smaller alkyl group. Then we get alcohol and the alkyl bromide will get, okay, which is possible with the HBr but not with the nitrate. Nitrate has a weak nucleophile. Br minus is a strong nucleophile, so it cannot attack. So C is not the answer, D is not the answer. So answer is option number A. Question number 5. They are given on compound here should be converted to NO2 group is converted to NH2 group. Reduction is there. Then COCl is converted into the alcohol. Reduction is there. Then the ester. Ester has been converted into the alcohol derivative. Correct? First one is the hydrogen KOH. This is meant for Wolff-Kishner reduction. Wolff-Kishner reduction only for carbonyl compound, pure carbonyl compound into the CH2 group. But pure carbonyl group is not there. Aldehyde or ketone group is not there. Then sodium borohydride. Sodium borohydride can be used for the acid chloride or the aldehydes or ketones. Okay, but you cannot convert NO2 to NH2 group. Not possible. Hydrogen palladium is the best one because it can convert C double bond or Cl. Okay, so if there is a hydrogen molecule like this, so it can give the aldehyde. Aldehyde further reacts with the hydrogen to give the alcohol CH2. That is there here. And esters are being cleaved. So we'll get ester. This is the ester. So with the hydrogen, what will happen? You'll get first as for you'll get aldehyde group and then alcohol. Aldehyde can be reduced to the primary alcohol. So alcohol is there. So ester becomes the alcohol. And NO2 group in the presence of the hydrogen palladium can be converted to NH2 group. So for all these conversion, hydrogen palladium is the best one. So answer is option number C, right? Question number 6. Phenols are less reactive than alcohols reaction involving CO fission. This is due to. Now we have got the phenol OH bond is there. If I take alcohol CH3OH, correct? In case of phenol, the lone pair of oxygen is involved in the resonance. So we'll get a double bond character. So we are going to get double bond character like this, correct? Double bond character. Double bond character not easy to break. In the case of methyl alcohol, say alcohol, there is no resonance. The thing remain at the carbon oxygen single bond only. Therefore, answer is option number C. C when phenol gets a double bond character due to the resonance. Question number 7. Which of the following compound will give 1 bromo 4 trichloromethyl benzene? This is a benzene. Let me write 1 bromo, 4th carbon atom, trichloromethyl benzene. Methyl is CH3. Trichloromethyl benzene it is. Okay. So Br and the CH3 initial compound should have been para to each other. Okay, so let's take toluene. I'll start the option number B. So toluene is subjected to bromination using the iron as the catalyst. Electrophilic substitution take place. Therefore, we get the para as the major product, para bromo toluene. Then carry out the chlorination using the sunlight or UV light. Heated, free radical takes place. We get the hydrogen getting replaced by the chlorine and benzene ring along with the Br. So this is the answer. So option number B is the answer. If you try with the other one, you'll get will not get the same product. Okay, right? Question number 8. Consider CH3, CH2, CH2. Propyl bromide reacts with the sodium cyanide. Cyanide will be attacking the Br and Br goes off. Okay. Nuclearly substitution reaction. This reaction will be fastest in. Now see here, these are primary alkyl halide. Primary alkyl halide undergoes nuclearly substitution reaction by SN2 mechanism. And SN2 mechanisms are favored by polar aprotic solvent. Polar aprotic solvent. And SN1 mechanisms are favored by polar protic solvents. Polar protic solvent. Ethanol, polar protic solvent. Methyl alcohol, polar protic solvent. Water, polar protic solvent. Okay. N, N dimethyl formamide. So this is the formamide, amide, formamide, NH2. Dimethyl formamide. This is a polarity there on the molecule. We can write polarity in the molecule. Delta plus, delta minus, polarity is in the molecule. But there is no OH group, there is no NH2 group. If there is a NH2 and OH group is there, it is called the protic solvent. So this is a aprotic solvent, polar aprotic solvent. Okay. So therefore answer is option number C. Clear? Question number 9. Which of the following derivatives are called unstable in the aqueous base? Aqueous base, if there is a base is a negative charge. You always look for the electrophilic center, which is the more electrophilic center. Okay. Now, if you see the example, see first option R, O, C double bond O and say methyl is CH3. So there is a carbonyl carbon, electrophilic carbon is there and oxygen negative charge. So base can be easily attacking. Okay. The carbonyl carbon and this OR minus can go off. So the answer is option number A. In other cases, there is no more of electrophilic carbon, not there anywhere. Okay, A is the answer, right? Question number 10. Which of the following compound is most reactive toward the acid catalyzed dehydration? Okay, once the dehydration take place, okay, so OH will be removed. It can form carbocation. If the carbocation is more stable, then the dehydration is easier. Now we have tried the structure of all the molecules and check which carbon is more stable. I'll take the answer itself, option number C. So carbon number 1, carbon number 2, carbon number 3, carbon number 4. OH on the second carbon, 2 butanol, and there is a phenyl group, benzene group on the second carbon atom. This is a CH3, CH2, CH2. So protonation takes place first. Water molecule is removed, so you get a CH3C plus here attached to the benzene ring. Then there is a CH2 and there is a CH3. And this is the carbohydrate resonance by the benzene here. Okay, very closer to it. So the answer is option number A. And after that, dehydration take place, right? And form the alkene. Alkene can be formed more stable alkene CH3C and benzene here, then double bond CH, single bond CH3. Clear? Right? So answer is option number C. Wishing you all students good luck for the coming examination. Do well in your NEET examination. May God bless you all. Thank you for watching.